Hi everyone, this is Nikhil and welcome to part 3 of the videos in week 1. As most of you replied that you are familiar with using CAD software like CATIA and SolidWorks, it is not worth spending a huge time in learning Autodesk Fusion 360. But if you are a beginner and want to learn in depth on Autodesk Fusion 360, click on this card above for a detailed playlist for learning Fusion 360. I will also leave the link to the playlist in the video description below, which you can follow along on YouTube. Now coming back to our video topic on getting started with Ultimaker Cura, I will give you a brief overview of this amazing slicing software and then we will dive into optimizing your 3D prints in more detail. So firstly, I will show you how to download and install Ultimaker Cura. So for that, first go to Google Chrome or whatever the browser you are using and then type Ultimaker Cura. So now you will get a link known as ultimaker.com, powerful, easy to use 3D printing software. Go ahead and open that link. And here it says Ultimaker Cura 4.10 download for free. Click on this link and select the operating system in which you are using. I am using Windows, so I will click on Windows. So now the file gets downloaded. So this is approximately about 200 MB file size, and as I have already downloaded, I will pause this and I will walk you through a little bit of settings which you need to use while installing Ultimaker Cura. So during your installation process, it asks you to plug in something known as Arduino. Okay, you don't need to plug in your hardware, but you need to click on that checkbox which asks for installing Arduino, and it also asks you for installing C++ Redistributables 2015. So please checkbox that also, and in the file types that asks you to support, please checkbox the OBJ, STL and 3MF file formats. And lastly, during the installation or after the installation, it asks for Adafruit enabler. So please enable that as well while you are installing Ultimaker Cura. I am not going to the detailed video on how you can install that, but if you want, I will make that in a later point of time. So after you download and install Cura, this is how the Cura slicing software looks like, and you can select your own 3D printer like this. So Ultimaker Cura has got about almost every 3D printer that is practically available in the market right now. So you don't need to worry about that, and you will be astonished by seeing what is the list of entire 3D printer library that's available inside of Cura. See, Ultimaker, Custom, 101 Hero, 3Dater, 3D Maker, 3D Tech, Anet, Anycubic. So there are so many 3D printer brands available which you can select from, and all the custom settings which are suitable for the 3D printer will be available to you inside of Ultimaker Cura. So that is the power of Ultimaker Cura. And as I am using Creality Ender 3 Pro, I will go ahead and create and click on Creality 3D, and inside of Creality 3D, these are the model names of the 3D printers. So I will go down here and click on Creality Ender 3 Pro, which I am using. So it doesn't matter, you can use whatever the 3D printer you are using, but you need to select the right one to be able to get the right settings for your printer. And after going to this, click on Add, and machine settings menu opens up like this. So all the printer settings like what is the width of the build plate, what is the depth of the build plate, and what is the height of the build plate, all these dimensions will automatically be pre-populated for you. So you don't need to worry about these default settings at the moment. We will come back to this later in more detail, but for now we will use these settings whatever are mentioned. And one more thing, the material diameter, that is the filament diameter for most of the 3D printers is 1.75 mm, but few of the 3D printers also offer you with inserting 2.8 mm of filament diameter. So there are two versions, one is 1.75 mm and another is 2.8 mm, but in most cases we'll be using 1.75 mm. So you should make sure that the right settings and the right dimensions are entered before you begin. So now I'm okay with these settings. You don't need to change anything and go to next. And after going next, you can see something known as generic PLA 0.4 mm nozzle. So this is nothing but the material which we will be using for 3D printing. So if you click on this, you will see a list of huge amount of material database that's available to you. So we will discuss about each and every material in more detail in a separate video, but this is just an introductory video. PLA stands for polylactic acid, ABS stands for acrylonitrile butadiene styrene, PETG stands for polyethylene terephthalate, and there are many other plastic materials and polymer materials which you can use for 3D printing. So for now, I am good with PLA, and the second setting is your nozzle size. So the most frequent or the most common size for your 3D printers is 0.4 mm. So that's the whole diameter of your nozzle, out of which the plastic material is going to melt and deposit onto your build plate. So 0.2 mm nozzle is the smallest dimension that is available in the market. So you can purchase your nozzle as per your requirements and you can install them on your 3D printer, and you can adjust these settings by coming back to this particular menu. So what is the advantage of using a small nozzle and what is the advantage of using a large nozzle? If you need more dimensional accuracy and if your design has more details and small intricate shapes, then you need to go for the smallest possible nozzle. But whereas you are not paying much attention to the detail, but you want your 3D prints to go faster and you want your 3D prints to happen at a large scale, then you will go for the maximum possible nozzle diameter. So currently in the market we have nozzle diameters up to 1 mm. So we'll discuss that in more detail later, but for now we will leave this at our default size of 0.4 mm nozzle. After that, the third menu you have the main settings which are used for 3D printing. So here the profiles are already default and you don't need to change much, but if you go to this particular custom button, you can see various custom settings relating to quality, walls, top and bottom layers, your infill percentage, material, speed, traveling, what type of cooling do you need, whether you need a support material, what kind of build plate adhesion you are using, and whether you are using a dual extrusion or not. We will see all of this menu in more detail in slowly as we go along this course, but for now we will not worry about this and I will close this and we will be using the standard quality settings. So for that, let me just close this. Now if you click on go back to recommended settings, these are the default recommended settings that are available. So if you can see the profiles, you have 0.08, 0.12, 0.16, 0.2, 0.28, 0.32. So this is nothing but the layer height which you can tune and tweak with. So as you know that 3D printing is an additive manufacturing process, the layers will be added one layer atop another and finally the 3D part gets printed. So what will be your individual layer height, that is adjusted in this particular menu here, and I will go with the default 0.2 mm of layer height. And secondly, this is infill percentage. So you will not be filling your model completely with plastic, but you will be using some patterns and leaving spaces to save the material. So 20%, 40%, 60, 80 and 100. 100 means complete solid model and 0 means completely hollow model. So I want somewhere between 40 and 60, so I will leave this at 50%. And right now I am not worried about the support material, so I will leave this particular box, and I am not worried about adhesion as well, so I will leave it empty. And I will go ahead and import my file. So how will you import your model into Ultimaker Cura? So as you have already known by this time that the file format which you will be using for 3D printing is STL. So let me open that for you and show you what is meant by STL file. So STL stands for Standard Triangle Language or Standard Tessellation Language, which was the language initially developed by 3D Systems, which were the pioneer in stereolithography, 3D printing, and modeling. So as you can see on the right hand side, whatever the CAD model you have, that will be transferred into triangles. So the machine will be moving along these triangles to able to understand and add material. So we will not be worried too much about what is an STL file and how does the machine understand this particular STL language, but it is good to know what is meant by STL and how your actual 3D printer is able to 3D print. So now, as you know that this particular file format will be used for 3D printing, let me show you how you can export your file into STL format. So this particular toy car is a model which I have built using Autodesk Fusion 360, and I want to convert this file into an STL file. So for that there are two ways. One is to go to your file menu here and go down and click on export. After you click on export, a menu like this opens up. And for the type here, click on this particular inverted triangle arrow and you will be seeing so many file formats into which you can export your model into. So if you scroll down a little bit, you will see STL. So after you click on STL, you click on this particular three dots button here which is mentioned, and you can select the folder in which you want to save your design, and let me give it this name. So I have given my car a name and I will click on save and I will click on export. After I click on export, Autodesk Fusion 360 takes some time to convert your model into STL file, and once it gets converted you will see status as complete, and after it's complete click on close, and now you can open your file manager, and now your particular file known as Formula E car model is now available. And if you right click on this particular file, you will be able to see that its property is .stl format. You can see it here. So now I want to import this into Ultimaker Cura. And this is one way in which you can export your model into STL file. Let me show you one more way. Let's say you don't want the entire file to get exported into STL, but you only need a few bodies. So how do you do that? Go to this particular bodies and expand by clicking on this triangle. So this gives me a list of the individual parts and bodies which I have used for developing this model. And if I want to only export this particular body, right click on that body and go to save mesh as. You can see this particular option as save mesh, and it opens up a dialog box like this one. So format is STL. So in STL you will be using binary format. So go with STL binary. Unit type will be millimeters. Don't check this preview mesh. Refinement will be medium. Okay. For most cases medium will be enough, but we'll see later on what is more used in more advanced way of refining your STL file. And you don't need to worry about all these right now, and what I'll do is just click on OK, and it opens up this dialog box for me once again, and let me save this as method 2. So in whatever the method you are using, it doesn't matter, but if you want the entire model you will use go to file and export as or save as option, export option. And if you want your individual bodies to be exported, you will use right click and go to save as mesh. So now let me open Ultimaker Cura, and I will go to the file menu and click on open files. And if I click on open files, it shows me these STL models. I will click on this and click on open. So now my model is open. So this is how your Ultimaker Cura looks like. So in order to rotate, you can use right mouse button. To zoom in and zoom out, you can use your scroll button. And for panning, you can click on the middle scroll button. So that's the way in which you will navigate your model. So now I want to rotate this particular model. So I will click on the particular body and I will go to left hand side and there is an option known as rotate. I will click on that rotate and it is showing me this particular 3-axis rotational system. So I want to rotate this model around Z axis by using this blue color ball. With the help of this blue color ball, I will be able to rotate my model as per my requirements. So after I am happy with the orientation, I will go ahead and click on slice. So it takes some time depending on your settings, and after it is sliced it shows me 12 hours 27 minutes. So that is the approximate calculated print time which will be taken by your machine. So here you have again two options. One is preview and another is save to disk. I will click on save to disk and I will say Creality Ender 3 Pro underscore car model G code 1. So this is the G code which will be exported and sent to the SD card of your 3D printer. So after you save, you have to move that file into your 3D printer. So some 3D printers come with online versions where you can upload your online files. Some 3D printers come with USB cable which need to be connected to your laptop, and some 3D printers come with SD card into which you need to insert this G code file. So as I have saved in my local computer and as I have not yet connected to my printer, I will not worry about print settings on my actual printer, but I will see how my model will be developed. So for that, just click on the preview option, and after you click on this preview option, you will be shown a menu or a window like this. So this contains each and every layer of your model, and on your right hand side you can see 232. So this is the number of layers which the 3D printer has to undergo in order to develop this model. So if you slowly move this particular button here, it shows in more detail how your model is actually 3D printed. So as I'm moving this up and down, it is showing me how your model is going to be developed, and you can understand this process in a more detailed way. And as you can see, we have used a 60% infill, and as you can see, the outer perimeters are fixed and internally there is some porosity. So this is nothing but because we given 50% infill. So 50% will be empty space and only the 50% of your model will get filled up with the plastic. So you can use these two buttons to understand how each and every layer is being built by the 3D printer. So that's it for this particular video. I hope you understood how we go with 3D printing your model, and in the upcoming videos we will go in more detail about how you can optimize your 3D prints, how you need to eliminate your defects, and what are the additional settings which you need to take care of, and how you should handle your 3D printer. All those things will be discussed in more detail in the upcoming videos. I hope I am able to give you a brief overview and brief understanding of the 3D printing workflow. Thank you very much for watching this video. If you liked it, please give it a thumbs up and please subscribe and hit on the notification icon to get instant updates each time a video is out. Thank you very much. With this, we will end part 3 and we will again see you all in part 4.